All right, so today we're going to talk about area of a circle and area of a sector. So we should already know the area of a circle formula. So that is A equals pi r squared. And then area of a sector, what that's going to be is kind of like your piece of pie. So if you were to pull out a piece of pie from a circle, that's what a sector would be. So it's just part of the circle, so finding the area of that. So the formula we get for that is the measure of the arc over 360 and then times the area. So it's almost like arc length, just instead of the circumference of the circle, we're going to multiply by the area of the circle. So let's look at an example here. So this says to find the area of sector GPH. So that's this piece here. So to do that, we're going to take the arc measure, which is 72 over 360, and then times pi times radius squared, which our radius for this picture is 15. So we're going to get, if we reduce this fraction here, we'll get 1/5 on the bottom, and then times 225 pi. So 225 divided by 5 is 45, and we'll leave that pi attached there. So our answer for the area will be 45 pi. The next type we're going to see is just an area of a segment. So segment's just part of a circle here. So we are looking at this part here. So to find that, you're going to take the area of the sector minus the area of the triangle, and that'll give you the part of the segment. So in this picture here, this is what we're looking at. So if you want to color that part in so you have a better idea of what that looks like. So again, we're going to take the area of the sector and then minus the area of the triangle. So to get the area of the sector, we're going to take the arc measure, which is 60 over 360. And then we're going to multiply that by our radius squared, so by 18 squared. So we're going to do 60 times 18 times 18 divided by 360, and that's going to leave us with 54 pi. So that's the area of our sector. Then we're going to do the area of the triangle. So our triangle here, 60 degrees, so that's going to be an equilateral triangle, so my sides are going to be 9 and 9. I'm going to pull out the small triangle here, so I get 30. This is 9, so my height is 9 squared root of 3. So to get the area of the triangle, I'm going to do base. So 18 times the height is 9 squared root of 3 divided by 2. So 18 times 9 divided by 2 is going to give me 81 with the square root of 3 still attached. So again, that's just the area of the triangle. So to get the area of the segment, I'm going to take the area of the sector, which is 54 pi, subtract the area of the triangle, which is 81 squared root of 3, and I'm just going to leave it like that. I'm not going to round it to the 10th or anything, so I can't combine those because those are not like terms, so I'm just going to leave it 54 pi minus 81 squared root of 3, which gives us a nice big decimal when you put that in the calculator. And the last type of problem we're going to see is where we have to work backwards from one of our formulas. So this one says to find the radius. So we first have to look in the picture what we're given. So we're given the central angle of 100, and then we are given the arc length here is 42.6. So I'm going to use the arc length formula, which is n over 360 times 2 pi r. Now I could use pi times diameter, but in this case it's asking for the radius, so I'm just going to use the 2 pi r. So that way when I get done, I have my answer for the radius. So again, I'm going to take n, so that's my degree, so 100 over 360 times 2 pi r, and that's going to equal my arc length, because that's what they give you. So my arc length is 42.6. So then from there, I'm going to simplify this. So on the top here, I get 200 pi r over 360. So if I reduce that, that reduces to 5 pi r over 9 equals 42.6. So I'm going to multiply both sides by 9. So I get 5 pi r equals 383.4. And then lastly, I'm going to divide by 5 pi. So when I divide by 5 pi, I get that the radius is 24.4.